This is problem 20 of chapter 20. So what we have here is during the 2000 season, the home team in the National Football League won 138 of the 240 regular season games. So they want to know, is this strong evidence of a home field advantage in professional football? So we're sort of the population of interest is sort of like all seasons, and we're using this one season as a sample. Okay, so they want to test the appropriate hypotheses and state a conclusion. So what we want to prove is that the home field, there is an advantage. So the home team has an advantage. So we could say something. So I'm going to write the alternative first because it just helps me organize. Sometimes this is what I want to prove. So the percentage of home team wins is greater than, and then here they didn't specify anything, so I think it's reasonable to say, well, if it was greater than half of the games, then that would be reasonable criteria maybe to conclude that there's a home field advantage. So that's great. I'm going to say greater than 50%. Okay, so P is greater than 0.50. All right, so that's my alternative hypotheses. So my null hypotheses would be the percentage of home team wins is 50%. So P equals 0.50. All right. So those are my hypotheses. Now my videos are getting a little bit long, so I thought I'd just go ahead and knock out some of the conditions real quick ahead of time. So plausible independence. So results of one game should not affect another, especially when we're talking about lots of different teams playing. This isn't just one team that plays 240 games. This is all the teams. So I don't think they're really related. Random sample. Okay, so it wasn't a random sample, and it wasn't some kind of sampling conducted by some professional organization. So the only thing we can do is ask ourselves, do you think that this is representative of other seasons? So in the NFL, over time, the game has changed a lot, but what we're talking about here is just home field advantage. So we're going to go ahead and assume that this season is representative of other seasons. Okay? And then 240 games is less than 10% of all games in all seasons. So you could go back. The NFL has been around since, I don't know, early 1900s. So we're probably good there. All right, so now let's do some calculations. So the sample size was 240. And so we have 240 times 0.5. So that's half. So that's 120. And again, Q is just going to be 0.52. So 240 times 0.5 is 120. So both are greater than 10. So the sample is large enough. Okay, so the conditions for inference are satisfied. So we can proceed with a normal model to perform a z-test. Okay, and this is going to be a one tail. Right, because we say greater than. All right, so the center of our model is 0.5. Okay, so mu is 0.5. And remember, this is p hat over here, so this is our sample. So we're going to have the square root of 0.5 times 0.5 divided by 240. Okay, and that is 0.0323. Okay, so that's our standard deviation. So 0.0323. So this would be 0.53, something like that, 0.56. So let's see, what is p hat? So our sample, what do we have? 138 out of 240. So 138 out of 240. So we're going to compare that result to the model. So that's 0.575. So it's got to be out here somewhere, right? This is maybe 0.6. No, this is 0.59. So 0.57, right in here somewhere. So p hat is right in there, 0.575. So it might be small, might be pretty small. Let's see what the z value is. So we're going to take the observed value, so that's right here, 0.575 observed, because we got it from our sample. The hypothesized value is 0.5, and we're going to divide by this reasonably small standard deviation. That's what's going to make z big. And so our z value is, as you can kind of see, 1, 2. So it turns out it's 2.32. Okay, so z is 2.32. So this area in here under the curve, that's our p-value. The p-value is the probability of getting this sample statistic given the null hypothesis is true. So given the model, which is just an extension of the null hypothesis, given this model, what's the probability of getting p hat? So we want to know what's the probability of getting a p hat value of greater than or 0.575, and so that's the probability of z being greater than 2.32. So 2.32 out to infinity, so all the way out, 9,999, and that turns out to be a very small number, 0.0101. So about 1 point let's just say 1%. All right, so what we want to do here is just up front, just tell me, don't beat around the bush, just tell me, are you going to accept or reject? So here, since the p-value of 1.1% is small, we reject HO. Okay? Since it's so low, there is strong evidence that the proportion of home team wins is greater than 50%. This provides evidence of a home team advantage. Okay, so that's the football problem, problem 20 of chapter 20. I hope that helps. Good luck.